Good day, students. So welcome to part 5 of the Integrated Algebra Regents exam for June 2013. In this installment, we're going to be going over questions 21 through 25. All right, let's take a look at question number 21. It says, Carol plans to sell twice as many magazine subscriptions as Jennifer. If Carol and Jennifer need to sell at least 90 subscriptions in all, which inequality could be used to determine how many subscriptions X Jennifer needs to sell? Okay, so Carol's number is described in terms of Jennifer's number. So Carol's number is dependent on Jennifer. So when declaring our variables, we're going to declare the independent variable first. Okay, so let number um, of Jennifer's subscription, I'm going to say let number of Jen equals X. Okay, and number of Jennifer's subscription equals X, then the number of Carol is going to be twice that. Okay, the number of Carol is simply going to be 2 times X. All right, now we're also told that the sum of their subscription sales is at least 90. So what does at least 90 mean? It means that it could be 90 or what? 90 or higher. Okay, so if it's 90 or higher, at least basically means that it is greater than or equal. It could be anything of that value. It could be that value or anything bigger. Okay, so to determine how many Jennifer will sell, we have to set up an equation where the sum of their sales will be greater than or equal to the total, which is 90. Okay, so at least 90 means greater than or equal to 90. So if we sum it up, we're going to have x plus 2x is greater than or equal to 90. Okay, all right. And now, all right, let's look at our options. The one that matches this, this matches that. We know that addition commutes, right? So we can also write it as 2x plus x is greater than or equal to 90. So our final answer is option number 4. All right, so there you have it. All right, let's shift our attention to number 22. It says when 2x squared minus 3x plus 2 is subtracted from 4x squared minus 5x plus 2, then the result is. Now when you're setting this difference of polynomial expressions up, you have to be really careful, okay? This term subtracted from this other term is written in the reverse order, okay? So the way you write it is 4x squared minus 5x is having the expression 2x squared minus 3x plus 2 subtracted from it. Okay, so this whole expression parenthesis is being subtracted from that, all right? So how do we evaluate this difference of polynomials? So to do this, we just simply distribute this negative to every term here, which results in the alternation of your signs. So we're going to have 4x squared minus 4x plus 2. That doesn't change. And this becomes negative 2x squared plus 3x minus 2. Okay, now just combine downwards. This becomes 2x squared minus 5 plus 3 becomes negative 2x, and then this is 0. All right, so we can clearly see that our answer is option number 1. All right, let's move on to question 23. It says, which expression represents number of hours in W weeks and D days? All right, so we just need to find the number of hours in a day and number of hours in a week, and then we can write down the expression. All right, so first of all, we know that there are 24 hours in one day. Okay, and then there are 7 days in a week. 7 days in 1 week. So how many hours are there in 1 week? Well, since there are 24 hours in a day and 7 days in a week, we can replace the 7 days with 24. This 7 days, each day can be replaced with 24 hours, okay? So this can be changed into 7 times. Instead of days, we can put 24 hours for the days, okay? 24 hours equals 1 week. All right, so if we multiply this out, 7 times 24 is 140 plus 28, which is 168 hours. So we have 168 hours in 1 week. All right. Okay, so we have enough information to set up our equation. Now, what we're going to do is we can do it one at a time. So if 24 hours equals 1 day, then what if you have D days? D days. What do you do to this to get to that? Well, you multiply this 1 by 24 in order to get the number of hours. So for D days, all we'll simply do is multiply this number of days by 24. So it's going to be 24 D hours for D days. Okay? All right, let's look at the weeks. If you have 168 hours in 1 week, how about W weeks? How many hours do you have in W weeks? Notice for 1 week, to convert it to hours, you multiply by 168. So how about W weeks? How do you convert this to hours? The same procedure, you multiply by 168. So you have 168 W hours in W weeks. Okay? So the total number of hours, total hours, is simply going to be the sum of D days is going to be D days plus W weeks. All right. So if we add this up for D days, we know it's 24 D hours. I could just write 24D. We don't have to put the hours there. 24D plus the number of hours in W weeks, which is 168W. Okay? Using the reflexive property of equality, we can express this as 168W plus 24D. These two equations mean exactly the same thing, okay? So 168 plus 24D. Our answer is option number 3, as you can clearly see here. All right? So that's that. All right, let's take a look at question number 24. It says, given R as 1, 2, 3, 4, A as 0, 2, 4, 6, and P equals 1, 3, 5, 7, what is R intersect P? Okay, intersection is basically all the elements in both sets, okay? Which one repeats in both of these sets? All right, so to find the intersection of two sets, what we'll do is list both sets and then basically find the elements, the set of elements that appear in both sets, okay? So don't forget, and basically means intersect. Intersect. And the U means union, okay? So in this case, we're finding the intersection. All right, so let's write down the 2. So set R is 1, 2, 3, 4. Okay? And then set P. Now, when you're setting up your sets and populating it with the elements, you must ensure that like elements are in the same column, so it's easy to find intersections, okay? All right, so put the 1 directly under the 1, and then the 3, I'm going to leave a space here, the 3 under the 3, and then there's a 5 and a 7. There's no 5 here, so shift this to the side, 5, and then 7, okay? So what's the intersection of these two? It's the elements that are common to both sets, okay? So 1 is common to both sets, so that's going to be in the intersection, and 3 is common to both sets, so that's going to be in the intersection, okay? So R intersect P is simply the set 1, 3. Sets that are the set of elements that are present in both of them, all right? So our answer is option number 3. All right, let's take a look at question 25. This is assessing our knowledge of how to set up ratios using right triangle trig. If you think about right triangle trig, the first thing that should come up in your mind is SOHCAHTOA, okay? It tells us the relationship between the angles and a pair of sides. Okay, now we're asked which could be used to find the measure of angle D in the right triangle shown in the diagram below. So this is angle D right here. So if this is angle D, how can we label our triangle? That's the question. If that's angle D, then the side opposite it is going to be the opposite. Okay, remember reference angle is angle D, so this side is automatically opposite. The side opposite the angle under consideration, the reference angle is always opposite. The side opposite the 90-degree angle is the longest side in the triangle, also known as the hypotenuse. Okay, so for all right triangles, the hypotenuse is always opposite the 90-degree angle. All right, and the third side is my adjacent. Okay, so since we're looking at angle D, we can set up sine, cosine, and tangent ratios for angle D. Okay, so let's start with sine first. Sine is so. What does so mean? So means that sine of the angle theta is opposite over hypotenuse. Okay, so in this case, sine of D, the angle under consideration, is the opposite, which is 12, over the hypotenuse, which is 13. So the question is, do we have this ratio present here? Absolutely. Option number 4 is our correct answer. Okay, so this is good. Let's try out the rest just to show you that they're false. K is cosine theta equals adjacent over hypotenuse. In this case, cosine D is going to be the adjacent, which is 5 over the hypotenuse, which is 13. Do you have cosine D equals 5 over 13 here? Nope. And then if you wanted to do tan TOA, we're just simply gonna have tan D equals the opposite, which is 12 over the adjacent, which is 5. Okay? So the only correct answer is the one that matches our first pair, which is first pair of sides, sine D equals 12 over 13. Okay? So there you have it. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking up here. And please post a comment to let me know what you think about this or if you have any questions. More clips on this can be found on myblogserver.com/testprep. You can find other installments of this review series, or you can just scan my QR code right here for direct access to this website. Thanks again for reviewing and have a wonderful day.